This lesson will be on 3-2, evaluating functions. First, a function is described as x values that can only be paired with one y value. We've already looked at functions by evaluating tables, mapping, and graphs, and now we'll be looking at equations of lines. When we're looking at equations, in order for this to be a function, we are not allowed to have an x squared or a y squared, so either variable squared. If we see an x squared or a y squared, this would tell us that we do not have a function. So either one of these. We are also not allowed to multiply the x and the y together. So if we see the multiplication of the two variables, that as well is not a function. We cannot divide by a variable. So if you see something like 1 divided by x or 1 divided by y, this as well is not a function. The last type is when we have x equals some number. If x equals 4, this is the equation of a line that is a vertical line, and remember, vertical lines are not functions. We can have y equaling a number. So all of these things would represent situations where we would not have a function, these 4 types. Next, we'll be looking at equations versus functions. If we take the equation y equals 2x plus 1, this is the equation of a line. In function form, the equation would be f of x equals 2x plus 1. Notice how both of the equations are exactly the same, 2x plus 1, but all we've really done is replace our y with f of x. F of x and y are the exact same thing. Remember that our y depends on our x, so in function notation, we're saying that if we replace our x with a value, we'll get a value right here for our y value. Now let's start evaluating functions. So given the function f of x equals 2x plus 5, we'll be evaluating in a f of negative 2. This means basically that we're replacing our x with a negative 2. So if we take the equation or the function 2x plus 5, but we replace our x with a negative 2, we can now evaluate that function. 2 times negative 2 is a negative 4 plus 5. Negative 4 plus 5 gives us 1, so f
I don't have a pass, but I was in the science collaborative talking to Mr. Talbot.
Okay, that's fine. In our next examples, we'll be using the same two functions, f of x equals 3x plus 7 and g of x equals x squared minus 2x. In our example A, we'll be using our f of x equation because it's f of k plus 2. And we'll be replacing our x with the expression k plus 2. So if we take our 3x plus 7 and we replace our x with the k plus 2, we're left with an expression. Because we're not inputting a number here this time, we're inputting an expression, our answer will be an expression. Our job is to take this expression right here and to simplify it. So if we do out the distributive property, we're left with 3k plus 6 plus 7. Therefore, our answer to f of k plus 2 is equal to 3k plus 13. In example B, we'll be using our g of equation, and we'll be replacing our x with 2c right here. So, given x squared minus 2x, we'll be replacing the x's with 2c. In our first part, we have 2c squared right here. This means 2c times 2c, or 4c squared. In our second part, we're given a negative 2 times 2c, which will give us negative 4c. We cannot combine our like terms right here, so our answer is simplified. So g of 2c is equal to 4c squared minus 4c.